What's the fastest way to write code? It's simple. Just don't write the code. I know this sounds crazy, but if we could use a crystal ball and figure out which of our code is destined for the trash heap, we could simply not write that code in the first place and save ourselves a lot of time. The fastest code we can write is the code that we preemptively eliminate because we realize early that we don't even need it. And it's a sad fact of software development that so much of the code that we write is going to go unused. Here's a less crazy way to look at it. Choose carefully the code that you decide to write. Be cautious where you invest your time. Decide to write code with the most obvious value and be wary of coding something with an unknown value. I asked this question, what's the fastest way to write code? Because I hope it made you think and because it highlights something important about prioritization. Thinking about where you can deliver the most value, thinking about where the best place is to invest your time, these are the kinds of thoughts that put you on track to being a more effective developer. So we've talked a little bit about the philosophy of rapid development. Now let's talk about the ingredients that we need for the development process that can make this a reality. At the heart of our personal work iterations is the coding cycle. Each small trip around our coding loop could produce working code. So we code a bit, we check the result to make sure it's working and fix any issues. We code a bit, we check the result to make sure it's working, we fix any issues, and so on. We are coding in small increments and testing and assessing the results each time. Why are the increments small? It's because small increments of code are easy to achieve, they are easy to test, and they're easy to prove correct. Testing is how we know that our code is working. I like to say this, if something is worth coding, it has to also be worth testing. Testing is a non-negotiable part of development. It is your responsibility to test your code and be sure that it works. When coding is done in small increments, the testing is easy. If you only write a few lines of code, then you only have to test those few lines of code. This is how testing is meant to be. It shouldn't be difficult. Coding and testing are supposed to fit together easily like this in a tight loop. Testing only becomes difficult if you bank it up to do later. It's only when you unfold the coding cycle over a longer period of time, you can really see its power. Imagine this sequence stretched out over hours, days, or even months. We start from simple beginnings, possibly just a single line of code. Then we work through a series of small changes. Each code change is small, simple, and easy to test. At no point in this sequence is testing difficult or overwhelming. That's because we baked testing into the heart of our coding cycle. Through this series of simple changes, we accumulate a large body of working code. We're building up step by step to a complex application. I just want to add, because this might not be clear otherwise, the duration of the coding cycle is usually shorter than the duration of your personal work iterations. So you can see in this diagram that there are multiple trips around the coding loop for each Pomodoro. So when I'm doing Pomodoros, every 25-minute block, I'm doing multiple loops of the coding cycle. With each code change, we should aim to bring the code back to a working state as quickly as possible. Working code, not broken code, is the output of your coding cycle. It's what defines the end of one cycle and the beginning of the next. So here's the key idea for speeding up your development process. To accumulate working code more quickly, we must reduce the distance between working states. There's two ways to achieve this. First way is to minimize the size of the change. That's small increments of coding like we just talked about. The second way, which is also very important, is to minimize the time it takes to test the change and verify working code. This is what we call fast feedback. This simple idea is so powerful and so easy to bring into your own development process. The more quickly you can check that your code is working, the faster you can make your pace of development. I'm going to give you a taste of what fast feedback is in a moment when I do my live demo. And I have a whole talk on my YouTube channel, which is called Code Capers, on using live reload to achieve fast feedback. So please look up my YouTube channel and you'll find the talk there on live reload. The natural state of code is to be broken, and it requires constant attention to be sure that it's working. Given this is the reality, how do we reliably capture working code? How do we preserve the output of our coding cycle? Well, the answer is version control software, which you most likely know as Git. It is the most well-known modern and mainstream version control software. So we need Git or something like it to capture the state of our code after we have tested it. Software like Git, it's very useful to developers for many, many reasons. Right now, I'm only concerned with its ability to track working versions of our code. The right time to commit your code It's at the end of every small increment of coding. At this point, you've made a code change, you've tested it, and you know that it works. Commit your code now before you break it. Now, you might think this is excessive, but I believe this is the most reliable way to put working code in the bank. Make a small change, test that it works, commit, and then repeat. You're banking working code. This also gives us a lot of freedom. So if at any point you get into a bad situation, like you've stuffed up your code somehow, you've broken something, you're not sure why your code isn't working, and you've made a mess of it or whatever, you have a way to back out of that situation quickly by resetting to the previous commit, which because that's the process we're doing, that the last commit is working code. I like to think of the git reset as a get out of jail free card. When you discard your working copy, you don't lose much code because you have been only doing small increments of coding, so there simply isn't much to lose. I've been talking a lot about testing, and you might have assumed that I was talking about automated testing. So this question could have popped into your head. Is automated testing worthwhile? Is automated testing worth it? The problem is that this isn't really the right question to ask. Here's a better question to ask. When is automated testing worth it? You might be surprised to learn that I routinely use both manual and automated testing in my own development process. The simple answer is that automated testing is often very worthwhile for code that is evolving, and hence, it needs frequent retesting, or maybe for code that needs to be very secure or very reliable. But automated testing, it is a big investment in your code. It takes a lot of time. It is an investment that can pay off because it can remove many hours of tedious manual testing from your development process. But you always have to ask the question, is my code worth it? Is my code worth the investment of automated testing? Only you can decide this. In my book, Rapid Fullstack Development, I will help you understand how to make the decision. And in just a moment in my live demo, I'm going to show you what it looks like to run a suite of automated tests. So what's JavaScript got to do with it? Well, this talk and my book are both called Rapid Fullstack Development. So full stack development, it is at the heart of what I'm talking about. Even though a lot of these techniques I've been talking about, they can be generally applied to any kind of software development. But let's start by noting that JavaScript is the only programming language that is truly full stack. Of course, if you're building a front end, a browser-based front end, you have to use JavaScript to build that. But we can also build backends, desktop applications, mobile applications, and more. In a moment, I'm going to show you an example of a mobile application in my live demo. And in my book, Rapid Fullstack Development, I cover all these uses of JavaScript in the example application. So there's going to be a backend, a web-based front end, a desktop application built in Ionic, a mobile application, got this all around the way, a desktop application built using Electron, and a mobile application using Ionic. So I'm covering all these use cases in my book, Rapid Fullstack Development, with examples of how to use JavaScript across the stack and also beyond the stack. Of course, I'm also talking about derivatives of JavaScript, like the most famous one, which is TypeScript, which personally I use quite a lot in my own development process. So there's a bunch of reasons why JavaScript can make you a faster developer, and being able to use one language across the stack is very important because it means you can go anywhere in your stack quickly without suffering a cognitive penalty for changing languages. JavaScript is a dynamic language, and that can really help us build a fast workflow. It makes live reload possible. I'm going to give you a taste of that in the live demo. It makes JavaScript great for dynamic and rapid prototyping, working with data. It makes automated testing much easier because it's so easy to mock objects in JavaScript. And then we can layer strong and static typing on top of JavaScript using something like TypeScript. The really amazing thing is that TypeScript can also be very flexible. So it's like we can mix and match the best of dynamic and static worlds using TypeScript. JavaScript has a huge and rapidly evolving ecosystem. For some newcomers, this will be very frightening or overwhelming. But as JavaScript developers, keep this in mind, we are very privileged to have such great tools at our disposal. We can pick and choose the tool set that best facilitates rapid development. We can select the tools that help us move faster and avoid the ones that slow us down. We also have some of the best tools of any programming ecosystem, and our tools are always improving due to huge community engagement. In particular, I want to call out some of the automated testing tools like Mocha, Jest, and Cypress. Testing in JavaScript is an absolute joy, and it's part of the bedrock of my own development process. Okay, it's time for a bit of a live demo. I'm going to show you some of the things that I've mentioned in this talk. The first thing I'm showing in my live demo is the test suite for DataForge. DataForge is my own library for doing data wrangling and data analysis in JavaScript. It works in both Node.js and the browser. You can look it up on NPM, or you can look it up on GitHub if you want to try it out for yourself. Here I am in my terminal. I'm going to run my tests. So by convention in Node.js, we run npm test to run our test suite. This is using Mocha, which you can see here from the command line. This big command line, I didn't have to remember any of that. I just had to remember npm test. So npm test is the convention that saves you having to remember the individual command for running the particular test suite. This is one thing that can help make you a faster developer, is to understand and use the conventions in your platform. Anyway, that was the test suite running. We've got hopefully all passing tests here. There's quite a few of them. In fact, I'm going to zoom out so we can get a bigger view of this. So there were 777 passing tests. It took 2 seconds to run that. Do you even believe that? That's pretty fast. Let's run that again, just to check that. One second. So this is what I'm talking about with fast feedback. I'm exercising almost every possible facet of this code in 1 second. And it's a fairly large library. There are thousands upon thousands of lines of code in this code library. I've spent many years building this up. Now I can run this in live reload mode. So if I do a run test watch, so this is the command that I use. This is my personal convention for running it in watch mode. So now that it's run all the tests, you can see it's just waiting for changes. So I'm set up now to start coding, to start changing this code, adding new features, editing the code that's there, whatever I'm going to do. It's automatically going to retest and show me. So this is a little bit harder to do on a laptop because there's not as much screen real estate. But I can get Visual Studio Code and I can get my automated tests side by side. Normally I work on a desktop where I've got a lot more screen real estate to be able to do this kind of thing. But I can make changes here. So what happens if I break this? What happens if I accidentally, a different number here, and I break that without realizing it? That's a pretty trivial mistake to make. I would hope that I would understand that. Hang on, what's going on here? Let's just try this again. For some reason, it's not picking it up. It's not a good demo, is it? Oh, good. I don't know what happened there. Something went wrong. Let's just try that again. So we're starting with 777 passing tests. Now, if I accidentally mistype a number here, put in something wrong in my code and just pretend I didn't realize that I did that, my tests will immediately tell me that something is wrong. At least one test is failing. If I put something here, probably a few more tests are going to fail. Okay, so I've got a failing test. I can easily fix that. And I've got all my passing tests again. So this is fast feedback, live reload in action. I can change my code. I can add new features. I can edit the code, and it will immediately tell me if I've broken something, if I've done something wrong. I'm just going to show you a git reset, actually, because I think, I promised I'd show that. Now, let's say that I've broken this code. I know what I've done. I mistyped a number here, but sometimes you're going to make a big change to your code and you're going to break something badly and you're not going to know why. And you could spend hours trying to figure out, what's wrong with it. You could spend hours trying to fix it. But the simplest way to fix it is just do a git reset, right? So, know what's there, know what you've changed. Let's just pretend that I can't figure out what's wrong, even though I can. Now, if I do a git reset hard, that takes me back to the previous working commit. So if I do a git status, nothing has changed. My code has been reverted, and my tests now should run. So I did a git reset. I'm back to all passing tests. I reverted my code. I lost some code, but because we're doing small commits, small code changes, small commits, when we do a git reset, we're not going to lose much code. Now let's do a quick example of doing some testing after the fact. So I wrote a large part of DataForge using test-driven development, which meant I wrote the code for the tests first, and then I wrote the code for the features of DataForge that would allow the tests to pass. You don't have to work that way. So TDD, test-driven development, is great for a lot of reasons, and it can teach you some really great skills to do with testing, and it can be a really good discipline to make sure that your testing does happen. But at the end of the day, what you want is the tests. It doesn't matter whether you did test first or test last. You just need the tests. So let's pretend, I'm going to show you a quick way to put a test in place. Let's pretend that I don't have this test, and I'm going to rebuild that test. In this case, I'm testing the standard deviation function of DataForge. And I looked at a maths textbook to figure out how to get that to work, how to do that. And I'm confident that I got the code right. So I've tested the code manually, maybe. I've verified it with a test book to make sure I'm right. I've got the code right. And now I didn't do TDD, but now I want to put a test on it. I want to write this test. So the interesting thing is that you can just write it. You can just write it after the fact. Call it the standard deviation test, save a bit of time. And I'll reuse this input here that I've got here. So I'm really just re-implementing this test, but showing you how I could do this after the fact. So these values are the input values that I got from the textbook. I might want to actually create a series from that, call the standard deviation function. And then I'm going to expect that my result is equal to something. But the question is what? What is it going to be equal to? I mean, yeah, I could look that up in the textbook, but maybe not to the precision that I want, or something like that. And how do I do it? Well, the simple reason is just to put in any value. Let's put in the meaning of life, 42, which is clearly going to be wrong for this test. But when I run this, when I save this and it reruns my test, guess what? It's going to tell me what the answer is. It's going to say it's not 42. This is the answer here. So I'm using the code that I know works to tell me what the answer is that should go in my test. So this is like the cheating way to write tests, is to write the code, manually verify that the code works, and then write the test that you need to kind of prove that works in the way it does. It's an alternative to test-driven development. Test-driven development is great as well, but we don't always get to put that amount of investment in our code that we can do that.